Hey guys, this week we're starting geometric sequences in series. So today we're going to be taking our notes for slides 8 and 9 about geometric sequences. So at the top of your paper, you can go ahead and put your title. First line is just sequence, that's what we talked about last week. It's just an ordered set of numbers. So we have like A1, that means the first term, A2 means the second term, A3, and then they just go on. So last week we did arithmetic sequences. That's when the pattern was adding the same number over and over and over. A geometric sequence is a sequence where each term is found by multiplying by the previous term a constant, or multiplying the previous term by a constant. And we call this number our common ratio. So last week we had a common difference. This week we have a common ratio. Just like the arithmetic sequences, there's two formulas. The recursive formula is the one where you have to know a term to be able to use it. So it's a sub n equals a sub n minus 1. That's the term that came before, times r. R is our common ratio. And then you have to give a term. Normally we give the first term, but technically it doesn't matter. So again, a sub n just means the nth term. This is the term before. R is our common ratio. And this technically can be any term. The way that you find the common ratio, so R is our common ratio. The way that you find it is you take any term and divide it by the term before. So ratio is a fraction, right? You take any term, divide it by the term before, and that's how you can find your common ratio. The explicit formulas, this is the one we use more often. You can use this to find any term that you want. A sub n equals a sub 1 plus r to the power of n minus 1. Unlike the arithmetic one, there's really no simplifying you have to do. Once you plug the pieces in, you're done. So n is the nth term. A sub 1 is our first term. And r is our common ratio. So this one can be used to find any term that you want. So we're going to do 4 examples. So for our first example, make sure you write it down. It says write the recursive explicit formula. So there's 2 different formulas, and then find the 15th term. So our sequence is 2, 14, 98. So when you're looking for your common ratio, right, you have to decide what number are you multiplying by every time. So like, what do you multiply 2 by to get 14? That's 7. And then 7 times 14 is 98. So the 98 times 7 would give you the next one, and times 7 and times 7 and times 7. That's our common ratio. If you can't easily identify it, you just divide your numbers. So if I grab my calculator and I divided 98 divided by 14 and 14 divided by 2, they should simplify to be the same thing. All right, so let's write our recursive formula first. So our recursive formula, I'm just going to use R for recursive, is a sub n equals a sub n minus 1. That part always stays the same. And then you just multiply by whatever your common ratio is. My common ratio is 7. And then we just list any term. Usually we list the first term. So the first term is 2. So the reason why we would have the recursive formula is instead of listing out all of our numbers, we can just give them this and be like, okay, you start at 2 and you multiply by 7. And that's the pattern of how you get your numbers. For our explicit formula, we have a sub n equals, you take the first term, which is 2. That's our first term. 2 parentheses r, our common ratio is 7 to the power of n minus 1. And then that's it. Unlike the arithmetic one, we don't have any simplifying or anything to do. We're done. We have our equation. The last thing that we need to do is find our 15th term. So the way you find your 15th term is you use the explicit formula, and you just plug in the number 15 or whatever number they want you to find. So a sub 15 equals 2 times 7 to the power of 15 minus 1. So we'll show our work. I know a lot of times you're going to use your calculator. You start with your exponent. 15 minus 1 is 14. And then you have to raise 7 to the power of 14. So 7 to the power of 14 gives me this huge number. And then I have to times that by 2. So what that means is it's 10 to the power of 12 means I move my decimal place over 12 times. We're just going to leave it in scientific notation because it's just too big of a number to write down. So scientific notation, you use 2 decimal places, 1.36, and then times 10 to the 12th. So big number. We're just going to leave it like that for now. Should have done a smaller term. Okay, number 2. So write down your example. All right, it says write the recursive and explicit formulas. So recursive, explicit, and I'm going to change this one because the same thing will happen on this one. Can you just change that to be the 5th term? We're just going to find the 5th term. And I might change that the one during class. We'll see. Okay, so find the recursive and explicit formulas. So recursive formula, again, you just start with a sub n equals a sub n minus 1 times whatever your common ratio is, and then you just give the first term. Okay, that's all you have to do for the recursive formula. So for this one, you're trying to find your pattern, like what number you're multiplying by every single time. So this one goes from 100 to 20 to 4. So you notice the numbers are going down. So that means you're dividing by something, which we still use multiplying. We will never have a division sign there. So what fraction are you going to multiply by to get the number to go down? So if your numbers are decreasing, if you're dividing by something, that just means that you're going to have a fraction. So maybe make yourself like a little note. Division equals fraction for r. So what number are we dividing by? 100 divided by 5 is 20. 20 divided by 5 is 4. That means our common ratio is 1/5. Dividing by 5 is the same as taking a fifth of something. So my r is 1/5. And then my first term is this one right here, 100. So another way you can find your r, remember, is you divide a term by the term that comes before. So 20 divided by 100 should be equal to 4 divided by 20. And if you simplify those, they're both equal to 1/5. That's your r. So you will never have a division symbol here. It will always be a multiplying. All right, let's give our explicit formula. So a sub n equals, you take your first term, which is 100, parentheses your r, which is 1/5, to the power of n minus 1. And then again, nothing to simplify, just like the recursive one when we're doing geometric. All right, last piece is finding, I changed it to the 5th term, so use your explicit formula for the 5th term, and you just plug in the number 5. A sub 5 equals 100 times 1/5 to the power of 5 minus 1. So I know most of the time we're going to use our calculator, so it'll be 1/5 to the power of 4. So in your calculator, first you do 1/5 to the power of 4, and then after you multiply by 100. Desmos, you could type it all in at once, but like if you're using like your iPhone calculator or something, you have to do it. So technically the Desmos, you could kind of type it all in as once. So I get 0.16. It is possible that if you were taking like a SAT or something and they had that this problem, they would maybe have it as a decimal, or I'm sorry, as a fraction. So to write it as a fraction, like if you move this 2 places over, then you put 16 over 100, and then you would simplify that. Like 4 goes into both of those, 4 over 25. So it is possible you would see it. So like back here at your original one, you know, the pattern was dividing by 5. So the next term would be 4 divided by 5. And then when you go 4/5 divided by 5, you would keep change flip, so it would be 4 over 25, because you would technically just start multiplying the bottoms by 5. So it would be 4 over 125, and so on. All right, 2 more examples. Number 3, it says, write the explicit formula for the geometric sequence whose 5th term is 6 and common ratio is -1/2. So something we haven't talked about so far is if your common ratio is negative, what that's going to do, so this is the 5th term is 6, right? So I have my 1st term, 2nd term, 3rd term, 4th term, 5th term, 6th term. So my 5th term is 6, and the pattern is -1/2. So that means I multiply 6 times -1/2. Well, a half of 6 is 3, so it'd be -3. So this would be going this direction, you're timesing by -1/2. Or you can think about that as dividing by 2, because taking a half of something is dividing by 2. So if I wanted to go backwards, okay, to find the 1st term, because we need that to be able to write the explicit formula, to go backwards, we would go ahead and instead of multiplying by -2, we would divide by -1/2, which is the same as timesing by 2, by -2. So 6 times -2 is -12, times -2 is 24, times -2 is 48, times -2 is 40, 80, 96. So something you need to know, if your common ratio is negative, what that's going to do to your pattern is it's going to change it positive, negative, positive, negative, positive, negative for all of your terms. So we're writing the explicit formula. So a sub n equals, you take your 1st term, which we found is 96. In parentheses, you put your common ratio, -1/2, and then it's the power of n minus 1, and you're done. All right, one more. It says, write the explicit formula given the recursive formula. So the recursive formula tells us our common difference, a sub n equals a sub n minus 1 times 4. I said common difference. Your common ratio, your ratio is 4. That means the pattern is timesing by 4. And then it gives us our 3rd term is 16. So I'm going to give you a different way of finding it than I did the last example. So when they give you a sub 3 equals 16, that's a sub n is 16. Your 1st term is what we don't know yet, but we're going to need it to write the explicit formula. Your common ratio is 4, and then the number of term that gives us 16, the number that you would plug in, would be 3. That's your n. So we can find a sub 1 this way, which is different than how I showed you guys up here. So 16 equals the 1st term times 4 squared. Well, 4 squared is 16, so I divide both sides by 16, and we get that a sub 1 equals 1. So when I go plug that back into my problem, I get a sub n equals 1. Technically, you don't even have to write it. The common ratio is 4 to the power of n minus 1. And that's my answer. So again, geometric means your pattern is multiplying by a number over and over. To be able to find it, you can just divide a term by the term that comes before. Pretty easy to plug them into the formulas. So these are going to go in on your notes on slide number 8 and slide number 9, and that's it. The homework is a Google Doc, I think.